how would we differentiate a fraction h of x such that it's equal to f of x over g of x? Well, the way I'd go about this is firstly writing h of x, so writing h of x as the product of f of x times g of x to the power of -1. Now I can allow myself to use the product rule, so let's proceed and use the product rule. So g of prime of x would be equal to f of prime of x times g of x to the power of -1 plus differentiating g of x to the power of -1, we would get -1 times g of prime of x times g of x to the power of -2 times by f of x. Okay, good. So let's write this as some fractions. We would get f of prime of x over g of x minus g of prime of x over g of x all squared multiplied by f of x. Alright, nice. Now let's write the left fraction as with the denominator of g of x squared, so we can write this entire expression as a single fraction. We would get f of prime of x times g of x minus g of prime of x times f of x all over g of x all squared. G of x all squared. Okay, so now I've just come up with an irreducible fraction which describes the derivative of h of x, which is the quotient of f of x and g of x. In mathematics, this is what is called the quotient rule. Now, this one rule over here can really help us differentiate many more complicated fractions. So rather than using the chain rule with the denominator to the power of -1, we can simply just use the quotient rule, which simply actually looks like the product rule. If you observe, looks like the product rule with a negative sign divided by g of x all squared. So let's try and do some examples to get familiar with this technique. Now in this example, you clearly see that you've done this before and you can use the power rule. So I'm going to use the power rule and I'm going to use the quotient rule. I'm going to compare both techniques. Okay, let's start off with the power rule. First, let's write h of x as x to the power of -1. Now let's differentiate it. So the derivative would be the exponent, -1, times by the function itself raised to the power of -1, take away 1, which is equal to negative x to the power of -2. Now this would be equal to -1 x squared. Alright, simple power rule done. Now let's try and use the quotient rule. So just a reminder, the quotient rule states that the derivative of h of x is equal to f of prime of x, such as, let me just write h of x is equal to f of x on g of x. So f of prime of x times g of x minus g of prime of x times f of x all over g of x squared. Okay, so we know that in this scenario f of x is equal to 1 and g of x is equal to x. So the derivative of 1 is equal to 0. So 0 minus g of prime of x, which is, since g of x is x, the derivative is 1. So 1 times f of x, and f of x is also 1. So that means we're simply taking away 1. So this is divided by g of x all squared, and g of x is x, so that means the denominator is x squared, meaning h of prime of x is minus 1 on x squared. Now, both techniques were pretty fast. However, I'd have to go with power rule in solving this. It's a much less formulaic way and much quicker. So, yeah. Now let's try this example. In this example, let's write out what f of x and g of x are. So we know that h of x will be equal to f of x on g of x. And we know that f of x will be equal to x minus 2. And g of x will be equal to x plus 1. So that means that h of prime of x will be equal to the derivative of f of x, which is 1, times by g of x, x plus 1, minus, so remember this is like product rule, but we put the minus in quotient rule, so minus the derivative of g of x, which is also 1, times by x minus 2, divided by g of x squared, which will be x plus 1 squared. Okay, so simplifying this, we will get x plus 1 minus x plus 2 over x plus 1 all squared. X is cancel out, we'll be left with 3, which will be 3 on x plus 1 squared. Alright, nice. So, decent example. Now let's try this one. So, we know that where h of x is equal to f of x on g of x, f of x will be equal to 2x minus 4, and g of x is equal to x squared minus 2x plus 6. So this means that h of prime of x will be equal to the derivative of the numerator, which is 2, times by the denominator, minus 2x plus 6. Remember, we always differentiate the numerator first, then we subtract it by the derivative of the denominator, which will be 2x minus 2 times by the numerator, which is 2x minus 4. And then we divide all this by the denominator squared. So x squared minus 2x plus 6 all squared. Now simplifying this, we'll get 2x squared minus 4x plus 12 minus, expanding this, we'll get minus 4x squared minus 8x minus 4x plus 8 divided by x squared minus 2x plus 6 all squared. This will be equal to 2x squared minus 4x squared, which is minus 2x squared. So remember, the minus goes in and multiplies by each of these terms, and then our two x terms will subtract to minus 12x, and then multiplied by the negative 1 we'll get 12x, and 12x minus 4 is 8x, and 12 minus 8 is 4. Okay, now we divide this by this, and we will be left with 4 plus 8x minus 2x squared over x squared minus 2x plus 6 all squared. Okay, now let's try this example. So in this scenario, we see that we have a product of two terms, and we have this one. I don't know who made this question. Wow, but this pretty. We just use a power rule. So yeah. So using over here, I'd recommend that. I think we can use the product rule. So we can differentiate this using quotient rule. We can differentiate this with chain rule. Or we could just bring this to the numerator and use the one big quotient rule problem. Make it one big quotient rule problem. So I'd probably use the product rule because you have to deal with much simpler derivatives. So yeah, let's try the product rule. So yeah, now h of prime of x will be equal to, firstly, the derivative of this, so d on dx of 3x squared minus 2x plus 4 over 4x minus 2 times x squared minus 2 to the power 4 plus d on dx of x squared minus 2 to the power 4 times by our crazy fraction 3x squared minus 2x plus 4 over 4x minus 2 plus this x to the power of 6, which I don't know why it's that. So differentiating this by quotient rule, we have to differentiate the numerator, which will be 6x minus 2 multiplied by the denominator 4x minus 2. I'm just going to remove this, 4x minus 2 minus the derivative of the denominator, which is 4, times the numerator. And all this is multiplied by x minus 2 to the power 4. And then it's divided by 4x minus 2 squared. Okay, nice. Now the derivative of this expression, we need to use the chain rule. So we're going to get plus 4 times 2x, which is 8x. So 8x times x squared minus 2 to the power of 3 times by our fraction 3x squared minus 2x plus 4 over 4x minus 2 plus x to the power of 6. Okay, so now all we need to do is simply rewrite all this, and the question should be done. So write all this in a single line, and yeah, the question's pretty much already done. So this will be equal to, actually we can expand this over here, but that would take a while, so I'm just gonna rub this out. Rub all this out. Okay, so let's expand this. So the expansion of this would be 24x squared minus 12x minus 8x plus 4 minus 12x squared plus 8x plus 16 minus 16, sorry. So minus 16 over 4x minus 2 all squared. This will equal to 12x squared minus 4x, and then minus 8x would be minus 12x minus 12 all over 4x minus 2 all squared. Okay, let's rewrite this. So h prime of x will be equal to 12x squared minus 12x. So I'm simply bringing this up here. 12x minus 12 over 4x minus 2 all squared multiplied by x squared minus 2 to the power of 4. Okay, and then this is plus 8x times x squared minus 2 to the power of 3 times 3x squared minus 2x plus 4 divided by 4x minus 2, and this is plus the derivative of x to the power of 6, which is 6x to the power of 5. Okay, so this is the final answer to this question. We simply use the product rule within our quotient rule, and we come to our final answer. And yeah, this is the quotient rule.